If you've never made a game before, or if you have made a game but you've never used Unreal, this is definitely the video for you. I'm going to teach you guys how to make a 2D space shooter game from scratch using Unreal Engine 5. I'm not going to assume you guys know anything else, and I'm going to go over everything as thoroughly as I can. By the end of it, you should have a fully playable game. So let's go ahead and get some assets. I'll have these links in the description as well. So go to this kine.nl website here. We want this Space Shooter Redux. Click download. You can donate if you want, or click continue without donating. And then go to that other link in the description, opengameart.org. And we want this space background right here. And then you just click on the name of it right here to download it. And it'll download. Easy. The next thing, if you don't already have Unreal Engine installed, you can go to their website here. I'll put this link in the description as well. Click Download Launcher. And after you've done that, it'll take a while. You'll eventually end up with something like this. You'll probably have this front screen when you open the Epic Games Launcher. You're going to want to go to the Library tab up at the top. And then under Engine Versions, you'll probably see nothing if you haven't installed it, of course. Click the little plus button. You can choose which version you want to install and then just hit install. I'm going to be using 5.6.1 for this tutorial video, but feel free to use an older version if you would like. And actually, before I go any further, I also have made this exact same tutorial in Unity as well. I'll put that link in the description. So if you want to learn Unity instead, or you want to learn both, then you can go watch that same project. You can just see how things are done differently in the two different engines. And then my friend over at Tutimic, his YouTube channel has a bunch of Godot videos, and he has this same tutorial video in Godot, and I will leave a link to that as well. Anyway, so the first thing we're going to do is click on Launch, and sometimes this takes a while to load. And then after that is done loading, you'll see something like this. So we are going to, over on the left side here, we're going to click Games. Make sure you have this blank template selected. Over on the right here, we're going to make sure that Blueprint is selected and not C++. We're only going to be using blueprints in this. Target platform, you can just leave that at desktop. Quality preset, if you have a really strong computer, you can just keep this on maximum. But if you don't, I would recommend putting it on scalable. And then once you're in the engine, you can adjust the graphics as you want. I'm just going to leave mine on maximum. Make sure you know where you're actually installing your game down here in the project location. And let's give it a name. I'm just going to call this Space Shooter 2D. There we go. And then click Create. All right, there we go. It'll probably take several seconds, even minutes for yours to load, especially if it's the first time you've ever done it. So just be patient. It will finish eventually. And this is what you're going to have, this open level. We don't want to use this. We don't want to use this big open level. So the very first thing I'm going to do before I do anything else is I'm going to go up to the top. I'm going to go to File. I'm going to go to New Level. And we want to choose this one on the right here that says Empty Level and hit Creating. And then here's our completely empty level. I'm going to save it right away. So I'm going to go to File. And let's see, Save Current Level. And in the Content folder over here, I'm just going to call this Main Map. You can call it anything you want. We'll save that. Okay, and then the very next thing I want to do is I want to go to Edit, and then Project Settings. And then over on the left here, up near the top, there's this link here that says Maps and Modes. Click on that. And here we have a default editor startup map. Right now you see it's open world. I'm going to change that to the one that I just made, which is main map right here. And then also for this game default map, I'm going to switch to my main map as well. That way, if you save this and come back to it later and you open your project up, it will always default to this new map instead of going back to the other one. All right, so before we really get into anything, I'm just going to do a quick overview of the user interface here in Unreal Engine. So I'll kind of start at the top here. So we have over here, there's some like viewport tools that we can move things around with. You can change the different modes from selecting, moving, rotating, stuff like that. You can change your coordinate system, world and local. We'll go over these in more detail later. Here's a little short hotkey buttons up here for switching between different movement modes. The little world here switches between world coordinates and local coordinates. Right here, you can turn on the snapping, and you can make different things snap, like angles, rotations, scales, positions, all that kind of stuff. And then you can turn each one individually on and off. And you can also choose what you want the snap size to be for the movement, the rotation, and the scale. And over here on the right, at the top, we've got different views. So I actually want to choose right now, I want to choose not perspective. I actually want to do front. Let's do front for now. So you can see that it's changed kind of what we see. It's not a 3D view anymore. It's just looking straight on. And this is what I wanted. So we'll leave it for that right now. Right now, wireframe is the mode. I'm going to change it to unlit instead. And so now we don't have to worry about any lighting or anything because we're making a 2D game. Then that's fine. So now we'll just show a couple more things up here. Don't really worry about these other things in the UI up at the top right now. You're not going to need them for this video, but you can change like the sensitivity of the mouse when you're zooming around in the camera and stuff. So if you right click and drag in the viewport, you can move and pan your view around. Obviously, the scroll wheel is going to zoom you in and out. And that's really about all you need to know as far as navigating in the viewport here, especially in 2D. And the next thing that's really important to know is the content drawer. So it's down in the bottom left. If you're coming from Unity, you'll recognize this as called the asset browser or whatever. So we have our content folder here. I went ahead and right click and went to new folder and created this maps folder just to keep things more organized. And I'm gonna just click and drag into there and say move here. There we go. And so now I have my main map inside my maps folder just for a little more organization. The hotkey to bring that up is left control spacebar. And by default, if you click anywhere else, it will automatically close that. If you want it to stay open, you can use this button over here on the right. It says dock in layout, and it won't keep closing like that. So if you do want to always be able to see it, you can just do that. The next thing I want to point out is over on the right here. We don't have any objects in the scene yet, but we will soon. There's this details tab over here, and this is going to show all of the information relevant to any object that you have selected. And it's like the inspector in Unity, same thing if you use Unity. And then up here we have the outliner, which is going to show every single object that's in your map. And that's the same thing as a hierarchy in Unity. And then down at the bottom, we have this output log, which is the same as the console in Unity, which you can write data to this for debugging purposes and stuff like that. So the first thing we want to do for our space game is get our background set up. So I'm going to go to the background that I downloaded earlier, which I have right here. And I am just going to, actually, I'm going to open my content drawer here. I'm going to right click, go to new folder, and I'm going to call this one textures. And I'm going to open it up. And I am going to drag in my space background. So there it is. I'm going to rename it just to make things easier. So that's my background. Okay, so I can't use it immediately like this because it's a texture. We actually need to convert it into a sprite, which is just the word used for 2D game images. So I'm going to right click on it. And then up here, it says sprite actions. And I'm just going to say create sprite. And then as you can see, it literally just makes a sprite from my background. So while we're here and while we're doing this, let's go ahead and get some more assets brought in just so we don't forget. And these other ones, make sure you open up the Kenny Space Shooter Redux folder. Unzip it if yours is zip, and then go into the PNG folder, just like this. So go into the PNG folder. And what we want to find right now is a ship that we want to use for the player. We want to find a ship that we want to use for enemies. And we want to find a laser for the player to shoot. So I'm just going to use this player 1 ship blue, and I'm just going to drag that out in there. And then I'm going to, let's go to the enemies folder. I like this one, kind of looks like a TIE fighter sort of thing. So enemy red 1, I'm going to drag that one in. And then I'm going to go back to the PNG folder, go to the lasers, and then I'm going to pick one of these lasers that I want. I want our player to shoot, let's say, red lasers. And I like this laser red 07 because it kind of fades out towards the back. So I will drag that one in. And that is the bare minimum amount of art that we're going to need. So remember, just before we forget, you're going to right click on your enemy that you dragged in and go to sprite actions and create sprite. And then we're also going to do that for our laser. And then we're also going to do that for our player. And now that we have our assets inside Unreal, we can put our background into the scene. So I'm just going to take this background sprite right here and just left click, drag it out into the scene and let go. So as you can see, we can't see anything, and that's because our sprite is just a 2D plane with no thickness, and our camera currently is looking at the front of the world. You don't have to follow along with this part, but I just want to show you. If I go back to perspective, you can see that it is in our world. Just if we look at it straight on like we were, it's, doesn't have any thickness, so we can't see it. So I'm going to go back to front view. And then all I'm going to do is over here in the outliner, I'm going to select my background sprite. And then now we can see what I was talking about earlier in the details tab or details panel over here. We have all this information that specifically relates to that background sprite. And I want to go to the location here, and I just want to make sure it's at 0, 0, 0, just so it's in the middle of our world, just so it just keeps things easier. And then in the rotation, I'm going to put it on 0, 0, 90. And now we can see the background. And I'm definitely going to want to scale it up. I'm not sure what's a good size right now, so I'm just going to kind of put in some numbers and we'll see. So for the scale here, it's at 111. I'm just going to put it at 222. This may be too big. I don't know. We can adjust that later. And now we're going to get into the fun stuff. We're actually going to make our player. So we're going to go to our content drawer. I'm going to go back to the main content folder, right click, new folder. I'm going to call this one Blueprints. So if you don't know what blueprints are, it is Unreal's proprietary visual scripting language. So instead of typing code like you would traditionally in Java or C# or something like that, we're going to use visual nodes that are connected with wires. Some people hate it, some people love it. We're going to open up our Blueprint folder here, and I'm going to right click inside of it. And then this time we're going to go up here and I'm going to select right here where it says Blueprint class. And we're going to do pawn. And I'll go over what these mean briefly. So anything that you can put in your scene is an actor. So this is the same as like a game object in Unity. It's just something that's in the scene. That's it. A pawn is an actor, except you can actually possess it and take control of it, and it can receive input and move around. So this is what you'd normally use for AI and also for human players. A character is also a pawn, except it has some additional behavior for like built-in movement. And then the player controller deals with solely input. It's not an actual physical thing in the level. And then we won't go into the other stuff right now. So anyway, click on pawn. And I'm going to call this BP underscore player pawn. And the convention in Unreal is to always put a prefix in front of your things. So this is a blueprint. So we put the prefix BP in front of it, an underscore, and then the name of what it is, and use Pascal case. So uppercase for the first letter, uppercase for the next word, no spaces. And let's go ahead and double click this and open it up. So here is our window that we see when we're looking at a blueprint. I'm going to left click and drag at the very top here where it says BP player pawn. And I'm just going to drag it up and dock it up at the top of my editor next to my map so I can easily switch between the two. So anyway, back in my pawn editor here, I'll just quickly go over what a lot of this stuff is. It looks like a lot. So over here on the left, we have the Components tab, and this is where you can add components onto your blueprint, which gives it, that's kind of what makes it what it is. So you can put 3D meshes on there, you can put 2D sprites, you can put lights, you can put all sorts of stuff. You can put components that change behavior. There's like collider boxes, there's all sorts of stuff. So Unreal uses this component system, and every object is basically just made up of a bunch of components. Down here, we have the My Blueprint tab, and you can see there are a few different categories here. So we have graphs, which are basically a workspace inside blueprints, and that's where you will place all of your nodes and write all of your logic, your gameplay logic. There are functions, which are kind of the same thing as a method in Unity. If you've used Unity, you can have them take inputs and you can have them provide outputs, and you can call them from other classes and stuff. Macros are kind of like functions, with the benefit that you can actually use like delays and like do something and then wait for 10 seconds and then continue. You cannot do that in functions. Variables are just containers to hold data, and event dispatchers are like Unity events. If you use Unity, basically you broadcast a signal out, and then anything that's listening to it can respond to that signal with whatever behavior it would like. And the last thing that's going to be important to know are events, and you can see we already have a few up here: begin play, actor begin overlap, tick. These are just things that when they get triggered, a bunch of stuff happens. So they're like functions, except they're not condensed nice and clean into one thing, and you'll see what I mean in a second. Up at the top here, you can see we have class settings and class defaults. So I'm going to go ahead and click on class settings here, and you can see there's really not much here. It just says what the parent class is, and notice we can change this if we want to, which we don't. We just want to keep it a pawn. And there's some other stuff here that you can change. The class defaults tab, this has all of our information for, collision, and is it replicated on the servers, or is it, only on the clients, stuff like that if you're making a multiplayer game. And then the most important thing, which we'll come back to, are the auto possess and the controller class. We'll come back to those very soon. You can also go to the event graph really quick. This is what it looks like. These are your nodes, and we'll get to those in a second once we actually start programming some behavior. So let's go back to the viewport here, and what we want to do is we actually want to make our player have an image. So we can use left control spacebar, or click on it in the bottom left to open up our content drawer. Let's go to textures, and remember we have this player one blue sprite, or whichever one you chose for yours. And I'm just going to click it and drag it and let go of it in the world. And so there we go. There it is. You can hold down right click and use WASD, just like you would in a first person shooter, to move around and look at your object. So that's pretty cool. So I'm going to, over here on the left in the component tab, I'm going to click on my sprite here, and you can see that there's a detail panel, and it has a bunch of information as well that is specific to this component, which is the sprite and not the blueprint itself. You don't really have to worry about this stuff much for now, especially for this example, because we're only messing with this one sprite really. So I do want to make sure that this is oriented correctly. So I'm going to, over here in the details, make sure it's at 0, 0, 0, which it is, but I want the rotation to be 0, 0, and 90, like that. So there's our rotation for our ship. And then the next thing that I want to do is, you'll notice we didn't have a camera. So like if we played the game right now, even if we put the player in the level, nothing would happen because we don't have a camera in the world. And what we're going to do for this game, just because it's a simple top-down, 2D shooter, we're actually going to put the camera on the player. So I'm going to click this Add button in the upper left in the Components tab, and I'm just going to search for camera. And it's just this top one right here that says camera. So here it is. you can see that things can be children of other things over here. So we have our player pawn at the top, and then as a child of that is the default scene root. Don't worry about what that means. And then children of that are the camera and the ship. So for the camera, I'm going to select the camera, and we're going to want to make sure the camera is in the right position. So as you can see right now, if we were to play the game, the camera is just pressed up against the player ship, which is definitely not where we want it. So I'm going to back it off a little bit. So over here in the camera's position, instead of 0, 0, 0, which is where it started at, I'm going to do -200, 0, 0. So now it's a little bit away from the player ship. This is mostly just for viewing purposes, just so it's easier for us, because we're actually going to make this camera an orthographic camera. So the distance from the player actually isn't going to matter anyway. This is just so we can see things easier. So make sure the camera's selected. And over here in the details, right here, there's this projection mode. And by the way, if you're ever having trouble finding anything over here, there's a little search bar at the top, and you can just search. So like if I type in Pro, okay, there it is, projection mode. We're going to change it from perspective to orthographic. Now there's ortho width, which is basically like how wide the camera's view is. So this is how you kind of affect zoom with an orthographic camera. Moving it closer and further away doesn't actually do anything. It's this ortho width. So I'm going to use the default, which is 1536. If that's not what yours says, change it. I found that to be a pretty good number to use for this. You may be wondering what the actual like units mean, like the camera being like, -200 away from the ship. So in Unreal, every unit, so like every one thing of distance moved, is a centimeter, which is different from Unity, where every one thing is actually a meter. So 100 units in Unreal equals 1 Unity unit. And 1 unit in Unity is 0.01 units in Unreal. So it doesn't really matter for this 2D game that we're making, and you'll see that soon. But just if you were curious what these units are actually measured in, they are centimeters. All right, so what we're going to do now is we're actually going to place our player in the world. Now, here's something very important. In Unreal, whenever you make modifications like this, whether it's to the code in the event graph or just components and details and parameters over here in the viewport, you have to make sure you come up here to the left and you click this compile button. You can see it's got a little yellow circle with a question mark in there, and that means I have not compiled it. So this is important to do always, or when you go to use it, all the changes you made won't have been updated yet. It also treats compiling and saving separately, so I'll show you how that works. So if I hit Control S right now, that little asterisk that was next to my class here means that I have saved this, but you can see it's still not compiled. So those are completely separate. So ideally, you want to compile and save. There's a little trick. If you click these 3 little ellipses right here next to compile, you can hover over here and it says save on compile, and I'm going to choose always. So every time I click compile, it will also automatically save. That's just how I like it. So let's jump back here to the main map. It should be up at the top of your screen. If it's not, remember, just open up the content drawer, go to your maps folder and double click, and it should open up your main map. Okay. So here we are back in the main map. I'm going to open up my blueprints folder, and then here you can see in the blueprints folder, I have my player. I'm just going to click and drag them out into the world. And if I hit play, let's see what happens. So, okay, things definitely don't look how we expect them to look. So let's go ahead and at least try to fix this a little bit. You can also see if I move around with like WASD, I can orbit around my player, which we definitely don't want. We want the camera to be locked and you can only move the player. So we'll fix that here in a second. This is one of the kind of frustrating things about Unreal, because the next steps are really, really simple in other game engines. Unreal requires a little bit more setup work, so we're going to go through that now. So go ahead and hit escape to stop playing. By the way, I don't know if I said it, the play button's up here at the top. You can just hit that green arrow up there to test out your game. So one reason that things looked weird is because if we go over in here to our outliner on the upper right, you can see that our background is at 0, 0, 0, which is the center of the world. but our player is at negative 30, almost 33,000. So I'm actually going to put the player right in the middle of the world. So I'm going to do 0, 0, 0. And so now if we hit play, the camera's way, way zoomed out, but you can see the player is way, way out there actually now on the background. So we definitely want that. But the next thing we need to do is figure out not only why we can't control the player, but also why the camera is not actually what our view is. So in Unity, all you would have to do is throw a script on it and write a couple lines of code and everything would be working just fine. It's not that simple in Unreal, unfortunately. So in Unreal, we have some work to do. So I'm going to go ahead and hit Shift-Control-S right now just to get everything saved so I don't lose anything. And then the next thing that I'm going to do is I'm going to go back to my player pawn blueprint. I'm going to go to the class defaults. And then over here on the right, you can see where it says auto possess player. Right now it's set to disabled. I'm going to set that to player 0. And what that's going to do is it's going to tell Unreal that we want this to be the thing that the player is actually controlling. So remember to hit compile. I'm going to switch back here to the level. I'm going to hit play again. And hey, look, now we're actually looking through our camera. And now after we've done that, our player is now possessable. However, our player can't actually receive any input yet. So we need to make sure that we can actually do stuff on the keyboard and the mouse to talk to the player. So go to your content drawer, make sure we're in our blueprints folder, and we're going to use another blueprint, and this one's called a player controller. So go to blueprint class, and then right here is the player controller. And as you can see, like I mentioned before, it just takes input and then passes it on to a pawn. So click player controller. I'm going to call this one BP underscore player controller. And I'm actually going to put the word space after it. And I'm actually going to go back and modify the player pawn to put the word space after it as well. Because the actual base class of the player controller, it's called player controller. So I want to make sure that I have that space ending so I know that I'm using the right one whenever we refer to it. Okay, so now we have our new player controller and we can open it up really quick. Just double click on it. And over on the right, you should have the class defaults tab open. If you don't, click on it up at the top. And then over on the right in the details, we want to make sure that this is automatically assigned, to our player. So over in the search bar in the details, if you just start typing auto, you'll see this thing here. It says input, auto receive input, which right now is disabled. I'm going to set that to player 0. So remember on our player pawn, we set auto possess to player 0. And then now on the controller, we set auto receive input to player 0. So now Unreal knows that whenever we're playing our game, as soon as the game starts, player 1 will automatically take control and all of their inputs will go through this player controller. And the pawn that the player controller is going to be controlling is our player pawn because we set that on auto possess. And make sure you hit compile. And now the next step is we have to let Unreal know that when we start our game, we actually want to use this pawn and this player controller. Otherwise, it might use a different player controller and a different pawn as the default player. So we're going to go back to our blueprints folder, right click, go to blueprint class. And then this time, we're going to want this game mode base. So just go ahead and click here on game mode base. And I'm going to call this one GP underscore game mode space, just like that. Okay, so I'm going to open that up. And you can see over here on the right in our details panel, if we have class default selected, we have this drop down that says classes. And you can see we have game session class, game state class, player controller class. And by default, the player controller class is just a generic player controller. So we need to click this drop down here and make sure we change it to our BP underscore player controller space. And then for default pawn class, instead of default pawn, we need to hit the drop down and change this to our BP underscore player pawn space. After we do that, make sure we hit compile. And now our game mode knows which pawn and which controller that we actually want to use. And the last thing we have to do is go up to Edit, go to Project Settings. We're going to go back to our Maps and Modes tab over here on the left, remember where we set our default maps. This time, up at the top, you can see where it says Default Game Mode. It's game mode base right now. We want it to be the game mode that we just made. So click the drop down and we're going to switch it to BP underscore game mode space. Okay, so now whenever we start the game, it knows that we want to use all of the options and the parameters that we set in this new game mode that we made. So before we move on, I just want to explain what some of the things in the game mode are. So you can either go back to the game mode that we made, or you can just click this selected game mode drop down here, and I'll just explain what some of these are. So the game mode is basically, it only exists on the server, and it defines all the rules of our game, which pawn we want to use for the players, which controllers we want to use for which player, our heads-up display that we want to use, and the game state that we want to use, and all that stuff. It basically defines like what type of game is this. The player controller is, of course, the input receiver. And whenever you're playing an online game or even a split screen or something, there is a unique player controller spawned whenever any new player joins the game, and they have their own player controller, and their player controller is going to take input from just that player, and then their unique player controller is going to possess their unique pawn. And so that's how when they put an input, only their player controller knows about it, and then only their pawn reacts to it. So you can think of the player controller as kind of like the mind of the player. And of course, the pawn is basically like the player's body and physical, what you see in the game. So then we have game state here. So game state, if you're playing on a multiplayer game, it's replicated to everyone, and this holds info that's good for the entire game for everyone to know, such as the score, the match time, it's like a card game, like what phase you're currently in, and it gets replicated to everyone on the server. The player state is essentially kind of just like the game state, except it's unique, and every single player has their own player state. So this is where you might want to keep data like that player's score, or what resources they have, or what team they're on, or their name, or their IP address, or their ping, whatever. You would keep that in the player state. So very quickly, kind of what happens whenever you start a new game is the first thing that happens is the game state is made. Well, first it reads game mode, and then that's how it knows what to do. So the game mode opens, it looks at all this stuff to figure out what to do, and then it will make the game state class on the server and replicate it out to everyone who's connected. And then the game mode will spawn a player controller for each connected player, and then that will then know, it will spawn a pawn to tell the player controller which spawn to take. And then every new player that joins gets a pawn. And then also every new player that joins also gets their own unique player state. And then basically whenever the game's running, any input that any player does goes into the player controller, and that handles all the movement and logic. And then that can also be used to like directly control their camera and UI and stuff. Stuff that's not like a physical object like the pawn. Okay, and finally, we're going to get to some actual programming. So let's go back to our BP underscore player pawn space. And this time, we're going to not look in the viewport here, but we're going to go to the event graph. And so you can see these are our nodes. And so think of a node as like, that's the action that's happening. It could be adding numbers together. It could be doing something super complicated. It could be dealing damage. It could be healing. It can be anything. There's 3 here that always start at default whenever you make a new blueprint. This first one is basically it runs one single time when this object enters the world. It's the same as the start method in Unity. This actor begin overlap is the same as on trigger enter in Unity, which basically just means that if this actor overlaps with another one, then this will happen, and then any logic that you have connected to it will then run. Event tick is a event that will trigger and run everything in it every single frame of the game. It's the same thing as the update method in Unity. Every node sometimes they have input pins and sometimes there are output pins. So over on the right here, you see we've got this this white like arrow. That's an output pin. Here we have this blue colored pin that says other actor. That's an output pin. If the pins are on the left side, they're input pins. And so output pins output some type of data, and input pins take the data into the event or the function or the macro to then do something with it. The white ones are a little special. They're actually not data pins, they're execution pins, and they are what controls the flow and the order that things happen in. The normal pins that are not those white arrows, they do not control the order that things happen in. The white ones do. So that's the difference between those two. Whenever we do draw things connecting nodes together, I'm just going to make a random node here. So whenever you have two nodes connected together like this, these are called wires. And so your wires will connect all your nodes together. So you can see what this is saying is whenever begin play happens, we're going to go through this execution pin, and then the next thing that's going to happen is it's going to destroy an actor. And what actor is it going to destroy? We have to pass in right here with the input pin what you want it to destroy. And by default, it says self, which means it's just going to destroy this object. So now let's go ahead and do our first super simple example of actually writing some blueprint code to make something happen. So remember how I said begin play just runs one time whenever this object enters our game world? So let's do something with that. So you left click on the pin and hold, and you drag it out. And then when you let go, it asks you what new node you want to place. There are thousands. So it's easier to know kind of what you're looking for and just search for it. So I'm looking for one called print string. You can see I typed print, and then here it is at the top, development print string. This is the one you want. What this does is it will print a message on our screen. You can expand it, and you can see these are Booleans. Do you want it to print to screen? Yes or no. Do you want it to print to the log? Yes or no. What color? How long should it show up? So let's say like 5 seconds for duration. And then for the string here, I'm just going to make it say, let's see, single event 5. You don't have to do that. You can leave it at hello. It doesn't matter. So I'm going to hit compile. Remember, if you don't hit compile, when we go to play, this won't work. Go back to your main map, and I'm going to hit play. And then in the very upper left of the screen, you can see that it printed off on the screen single event fire, and it will stay there for 5 seconds and then disappear. So let's go back to our pawn. And so we know that when the begin play event was triggered, it actually did print our string. So to break one of these wires connecting pins, if you hold Alt and click, it just completely breaks it. If you hold Control and click and drag, you can then move it to a different pin. So I'm going to hold down Control, left click and drag, and bring it down here to event tick. And so now, instead of being, this message printing one time when begin play is called, it's going to play every single frame. So I'm going to set the duration down to like 1. I guess it doesn't really matter. I'm also going to change the color to make it a little easier to see. Let's do like an orange. And this one, I'm going to change the text. Again, you don't have to do this. I'm just going to change it to every frame. Remember, hit compile, go back to our map. And now when I hit play, look, every single frame, it's printing off that message. So you can see why you have to be careful using event tick because if you put a bunch of logic happening in here, all of that has to run every single frame, and it can get kind of resource intensive. Okay, so I'm going to delete this print string. You can click and drag. You can just click on it and just hit delete, and you can get rid of it. So the next thing that I want to do is we actually want our player to move. And so for this game, I want the player to move with the mouse as opposed to like keys. So basically, what we need to do is we do need this to happen every frame, because as the player is moving their mouse, we need to know where it is at every moment in time. So if you want to place a node and you're not clicking and dragging off of something, just right click anywhere in the graph. And the name of the node that we want is get local viewing player controller. And don't worry, over time, you'll start kind of memorizing the names of the nodes that you use a lot. And what this does is it's just going to return the player controller that is looking at this pawn, which obviously this is a single player game. So this pawn is controlled by the only player controller that there is. And then what we want to do is drag off of here. So the return value is what it actually gets. So this is actually going to be the controller. And so we're going to drag off of the controller, and we're going to look for a node called get mouse position. And it's this one under the player tab. It should look like that. So you can see for the input, it's taking a player controller, and then it outputs an X location, a Y location. And then this is just a true or false that gets pointed out. If there is no mouse connected, this will return a value of false. We don't need to use that for anything, so we don't really need to do anything with that. So what we do need to do, though, is we need to make sure that our mouse position, which is just an XY position on the screen, is turned into an actual world position in our game. So we need to convert the mouse position to a world position. So we're going to right click, and this node is convert screen. Okay, so you can see I'm typing and it's not showing up. If I unclick this context sensitive thing, it will show everything. It tries to guess what nodes you might mean. Sometimes it doesn't work. So I'm going to turn that off just for this. And the one I want is the convert screen location to world space. So this will take a 2D location on our screen and convert it into a 3D location in our world. And we're going to connect the location X of the mouse to screen X, and location Y to screen Y. And then, as you can see, the output here is the actual location that we want to use. So I'm just going to move this down here for a second. And again, I know blueprints can be really confusing, especially for people who are used to traditional typed programming. So again, this get local viewing player controller, it's just a method. It's a built-in like Unreal method. It takes a pawn as an input and it outputs the controller. So then we're sending that controller as the input to this get mouse position method, which is outputting two floats, our X and Y location on the screen. And then those are being fed in as inputs to this convert screen location to world space. And so it just does all the math behind the scenes to turn our 2D screen space into 3D world space. And as you can see, the outputs of this are the actual location, a direction, which we're probably not going to need to use, and then also a return value if it failed or not, which we don't need to worry about that either. What we do need to do, though, is our player we want them to move only left and right. I don't want them to move up and down, and I certainly don't want them to move like deeper away from the camera or closer to the camera because it's a 2D game, so we don't want to do that. So this world location, it's a vector, and it represents, the entire XYZ location in the world. I actually don't want that, so I'm going to drag off of world location, and I'm going to type break. And there's this break vector. And what this does is it will take that single XYZ vector and break it and let us see the individual pins. So we have each individual coordinate here as a float. So now we can, do a little bit more with them. So the next thing I want to do is I'm going to right click and I'm going to do make vector. And what this is do is we're going to make a completely new vector with any numbers that we want. So our player, if we go back to our map, you don't have to, but I'm going to. If we go back to our map and look at our player here, we can see that this green arrow represents the Y location of the world. And I want the player to move left and right like this. So we know that we want the Y to be the thing that we are actually controlling with the mouse. The Z, which is his, up and down, we actually don't want to move. And then, of course, the X, which is towards us or further away from us, we want that to always stay at 0. So back here in our player pawn, it's pretty simple. So Y is the only one that we want to do anything. So we're just going to drag from Y to Y and connect it. And we're going to make sure that X is 0 and that Z is 0. And then this return value is the new vector that it's making. And remember, we want to move our player to the point that this whole thing is calculated. So we can drag off from the return value pin, or you can just right click. It doesn't matter. So I'm going to drag off of that, and then I'm going to do set world location. So for those of you coming from Unity, we use the word position for everything in the world, and Unreal uses location. So that might take some getting used to. I know it did for me. And then we're going to drag from the output execution pin of event tick and connect it to the input execution pin of set world location. Now, it's also saying what do we actually want to set? So it says, it's setting something to a certain location, and by default, it just says self. Well, I actually don't want to move the camera. I don't want to move the entire scene root, which will move all the children with it. I only want to move the sprite. So I'm going to left click on the sprite over here in the components, and I can actually drag it out into my graph. And so here we have a reference now to the actual sprite that represents just, visually what the player is. And so that is what I'm going to connect to the target. I don't want to move the camera. I only want to move the sprite. I want the camera to stay where it is. Okay, so if we go into our game now, this should work. So let's hit compile. Oh, okay. It says, self is not player controller. We need to do that. So this convert screen location to world space needs to know, it needs to have a player controller, and I didn't have that connected. So we'll hit compile. Now it'll work. Let's hop back into our game. Let's hit play. And now, as I move my mouse left and right, my player will move with it. And if I move the mouse up and down, nothing happens. So one other thing is that I actually don't want my player to be right in the middle of the screen. I actually want them to be like down towards the bottom. So we'll change that. And actually, before we move on, I want to fix this camera doing this thing that it's doing. Basically, Unreal's not really meant for 2D games. And so by default, it wants to use all of its fancy lighting stuff and everything. But in our world, we don't have any lights at all. And you can see that it's trying to compensate for that by like auto adjusting the camera. So let's go back to the BP player pawn space, select the camera, and there's just a few things I want to change. So let's try this first. So in post-process, under lens, let's look for bloom. And remember, you can just, if you can't find it, just search for it up at the top. And it should, you should find it faster. So let's go to bloom and let's set the intensity, check that, and manually set the intensity to 0. And then down here on exposure, check this metering mode, set it to manual, check both of these, and uncheck that one there. So it should just look like this. Let's hit compile and let's hit play and see if this fixed things. Okay, so our sprite's still a little brighter than I think it should be, and the background's slightly discolored, but I think this is about the best we're going to be able to get this. Like I said, Unreal is not really meant for 2D games, and it's hard to make it not use the lighting that it wants to use. So, okay, so now we can move on. Like I said, I don't want the player to be in the middle of the screen. I want them to be more towards the bottom. So let's go back to our blueprint here for our player pawn. And basically what I want to do is I want to leave the camera where it is. And I just want to select the sprite itself and basically drag it down so that it is more towards the bottom of the screen. So this is going to take some trial and error to kind of get it where we want it to be. Negative 375. Compile. Okay. But we have a problem. When I hit play, they jump back to the center of the screen. And the reason why, if we go to our event graph, you can see every single frame here, we're getting the mouse position, and then we're setting the mouse position Y to match where the setting the player to match where the Y is. But we're also setting the Z to 0. Well, we don't want to set the Z to 0. We want the Z to be, whatever it is when it starts. So if our player starts and his Z is all the way down here at negative 375, we want it to stay there. We don't want it to, change it to 0, which is what it's doing right now, right here in this make vector. So let's figure out a way to make it so that when the game starts, it doesn't matter where its Z is, it just stays there. So I think the easiest way to do this is I am going to just right click down. Actually, I'll show you how. Let's make a method or a function. So over on the left here, where you see this functions thing, just click on the little plus button right there, and we're going to make a brand new function. And I'm going to call this get vertical position. And this is going to be getting that initial vertical position of the player. So remember, we don't want to find out where the object is. We want to find out where the actual sprite is. So we're going to drag in the player sprite, drag off of the output pin, and we're going to do get world location. And here's something that's really frustrating. That was the wrong node. There are a lot of different get world locations. Look, there's literally 2 called the exact same thing, but the one we want is this transformation get world location, like that. Now, we don't need the entire location, we just want the Z. So we can, remember how before we dragged off and I said break vector? There's another way to do this. For the return value, you can right click on it and say split struct pin, and it'll just split it right there. I actually want to make this a variable. So there's a few things we can do. We can go over to the left and click this little plus button and make a variable. But something cool you can do is I can right click on the return value Z and say promote to variable. And you'll see what it automatically does is it automatically makes a variable over here of the right type. And I'm just going to rename it start Z position. And you can see it automatically made the node and connected it. And then all we have to do is connect that just like that. And so now we have this enclosed self-contained function that is going to take our ship, find where they are in the world, and then save that as a position. Make sure you hit compile. Up at the top, we can close this function, the little box, and we can go back to our main event graph. And then now, over here in our functions, we can just drag in our get vertical position function anywhere in our graph. And I'm going to connect it to event begin play so that as soon as the game starts, it's going to call this function and it's going to save our Z position. And then we have to use it. So down here in our make vector, instead of making Z 0, we're going to drag in this start Z position Now notice when you drag it in, it says, do you want to get the variable or do you want to set the variable? We want to get the variable. We don't want to change it. We just want the value of it. And if you control click when you drag it out, it's always getting. And if you alt click when you drag out, it is setting. So if you don't want to drag it and then pick, you can use the control and the alt short keys. Anyway, then we'll connect that up like that. So now our start Z position is connected to this make vector. Let's hit compile. Let's hop back in our game, hit play. And now you can see our ship is actually, towards the bottom of the screen. And actually I want them to be even further down. So I'm going to go back. And then, like I said, the reason this is so cool is because we don't have to keep changing this number. It'll just update automatically. So I'm going to change them to minus 650. That's I think, going to be my final value. Okay, cool. Yeah, that works for me. So he's locked to the bottom. He's locked to only moving to the edges of the screen because obviously our mouse is confined to the screen and we can't move off of it. And that's great. So I have all of that working just how I want. So the next thing we need to do is we need to make it so the player can actually shoot a laser at the enemies. So remember our laser that we drug in earlier that we made a sprite out of. So that's what we're going to use. So we're going to go back to our blueprints folder and just how we made the player, we're going to right click. We're going to go to blueprint class. But this time, we're not going to choose a pawn because we're not controlling the laser. It just needs to be something that exists in the world. So we're just going to choose actor. And I'm going to call it BP _ laser. Let's open it up. And then open up our content drawer. Go to our textures folder. Take our laser sprite and drag it into the scene. There it is. And then I think we're also going to need to rotate this. So let's set the Z rotation to 90, just like that. And yeah, that should work. Okay, so we rotated it 90. That's all we have to do. Let's leave everything else, the location 0, 0, 0, and just keep everything like that. So now let's go into the event graph. We have to ask ourselves exactly what do we want this laser to be doing. And so all I want it to do is I just want it to spawn and I just want it to move up, like straight up, continuously at a set speed. So not too hard. I do, however, want to make a variable so that it's easy to change the speed later without having to manually type different numbers in if we change. So over on the left, for variables, I'm going to click. We're going to add a new variable just called speed. Now notice right next to it, it has this dropdown and it says Boolean. We do not want it to be a Boolean. We want it to be a float. So click the dropdown and you can see all these different data types. One cool thing about Unreal is that every data type has a color associated with it. So over time, you'll start to memorize that light green is a float. This kind of turquoise is an integer, yellow is a vector. We saw some of those earlier. And reds are Boolean. So we want to make it a float. So we have this speed for float. Now, another thing I want to show is if you have this new variable selected, over here on the left, there's this looks like little eyelashes. They're closed. You can click that and make it an open eyeball. You can also do that over here in the details. It's this instance editable checkbox. You can click that on and off, and that does the same thing as clicking on the eyeball over here. And we want it to be instance editable, and I'll show you why in a second. We might not use it, but it's a good thing to know how to do. So we'll just do that for now. And then now that we have our speed, let's hit compile. And now if we click on our speed, you can see over on the side here in the details, there's a default value speed. And I'm just going to put it at like 100, I guess, and we'll see how that looks. And then what we want to do basically is we just want it to every single frame move a little bit further upwards. That's it. So we're not going to need event begin play, and we don't need actor begin overlap, so we can delete those. But we do need to use this event tick because we want something to happen every single frame. We want it to move a little bit so it moves the screen. So what I want to do is right click, and we're going to do add vector world offset. And what this does is it takes the world location that they're already at and then adds a little bit to it in a specified direction, and then also a specified distance, like 10 centimeters or 1 centimeter or whatever. So I can right click on delta location and do split struct pin so that we can see all the individual things that make up this vector here. And so if I just type in 100 right here into delta location Z, then it'll make me move up, or make the laser move up at 100. Obviously, like I said, we don't want to just hard code numbers in there. We want to use our variable. So we'll drag out our speed variable and connect it. So there's one problem with this right now. Remember, event tick is ran every frame. So if you're playing on a computer that runs at 60 frames per second, every second it's going to move 60 times. If your monitor is really crappy and you're running at like 10 frames per second, well, then in 1 second, it's only going to move 10 times, but the same amount each time. So basically that means depending on what computer your players are playing on, the laser is going to move either slower than you want it to be or faster than you want it to be. And it might be different on everyone's computer. You absolutely, definitely don't want that. So what we need to do is we need to actually right click, and we're going to make a new node. And you can just type the little asterisk, like the multiply symbol. And we want to multiply. And what we want to do, and again, you can hold Alt and click to break a wire. We actually want to multiply delta seconds by the speed, and then we can feed that into Z. What delta seconds is it is a number, it's a float that represents the time between the last frame and the current frame. So if you're running at an extremely high frame rate, that number is going to be different than if you're running at a really slow frame rate. And what this does is it makes it so that your laser is going to move the exact same speed no matter what computer you're running on and what their frame rate is. And then also, even if they have like dips and peaks in their frame rate, it will automatically compensate for that. And the laser is always going to move at the right speed. So I'm going to hit compile. Let's go back to the map and let's just test that out. So let's take our blueprint for our laser here, and I'm just going to drag it out into the world. And so you can see there we have our laser. Now, one thing is you can see the lasers like behind the background. One, because its location you can see is really off. So I'm going to set the location of the laser back to 0, 0, 0. So now there it is in the center of the screen. I'm going to drag it down a little bit. And again, it's like behind the background. So we can select our laser. If we select the actual sprite itself in the rendering tab, we can change. There's this advanced dropdown. If you scroll down, there's this translucency sort priority. This basically means you can put in numbers here to choose in a 2D game what gets drawn on top of what. So I'm going to set this to like 1. And I'm going to select our background. And I'm going to make sure that this translucency sort is like -10. So the background's like always in the back. And the last thing that we might want to check is making sure that this laser that we brought in actually is rotated. Remember, I rotated it and said I think we need to rotate it, but maybe we don't. You don't have to leave out of this front view. I'm just going to do it really quick. I'm going to switch to perspective view so we can get a 3D view of our laser. And so, yes, it is correct. It is right. But in this front view, the background's being drawn on top of it, but that shouldn't matter. When we hit play, it should readjust and change. So I'm going to drag the laser down to the bottom of the screen so we can watch it, move up. I'm going to hit play. And our laser is, well, let's see. Oh, there it is. Yeah. So it is moving. It's just really, really slow. So obviously 100 is way too slow. and it started way too low as well. So let's start it like right there. There we go. So that's still too slow. So remember earlier when we made this a instance editable thing? So this is why. So I'm going to click on the laser over here, and you can see that over in our details, we actually have that speed variable that we defined. You don't have to go back to the blueprint. We can actually just change it right here. So let me set that to 500 and let's see how fast the laser is. Okay, I think that's still a little slow. 1000 might be too fast, but let's try that. Okay, for right now, I'm going to leave it at 1000. So that's why it's cool to do that instance editable thing. You don't have to go back to the blueprint. You can just type it there and do some testing. So I'm going to delete the laser that we have in the scene now, because of course we don't want the laser to start in the scene. We want the player to actually be able to spawn the laser. But before we do that, I'm going to go back to the laser. I'm going to select the speed variable, and over on the right, I'm going to change this default value to 1000 because we know 100's too slow, and then hit compile. And then now our laser should be working just as we intended. And all we have to do now is make sure that the player can spawn these lasers into the world. So let's go back to our player. Let's go to our event graph. And what we want to do here is spawn the laser. That's it. So right click anywhere. This is our first custom event we're going to make. So just type custom, and we want to do this add custom event. I'm going to call it fire laser, just like that. And then the way that you spawn objects in Unreal is a node called spawn actor from class, just like that. And then it's going to ask you, what class do you want to spawn? Well, we want to spawn our laser, so we can hit that drop down there, search for laser, and input BP laser there. Let's go ahead and connect those up so that actually works. And it wants to know where we want to spawn the laser. Well, for right now, I just want to spawn the laser where the player is. So how do we do that? Well, we need to make sure we get the player's location. So I'm going to drag from the left in the components, drag the player sprite back in here like this. Then I'm going to drag off of it, do get world location. Remember, the top one's wrong. We found that out last time. In fact, it's probably because I have this context sensitive turned off. I'm going to turn it back on, and then there we go. Now we're getting the right ones. And you can see if I just do this, get world location, it actually knows, like, hey, do you want to get the camera, the root, or the sprite? I want to get the sprite, so it'll just make it and connect it for me. So that's pretty cool. And then this is outputting a vector, but the spawn wants a transform. So a transform is the location, the rotation, and the scale. But this get world location only gives us a location. So not a big deal. Connect it up anyway, and you'll see that it'll just make this little conversion node for you. And all that does is it's just changing this into a full transform with the default values for rotation, which would just be, 0, 0, 0, and then the scale of 1, 1, 1. So that's it. That's all we have to do. And that should spawn our laser. There's some extra things here, like this collision thing. You can make it so it won't spawn if it spawns inside of something, or it always spawns or whatever. We're going to leave it at default. Hopefully it doesn't cause any issues. If it does, we can come back. So I'm going to hit compile. Now, so here's the thing. We have this event that we just made to spawn lasers, but we don't actually have a way to, we're not calling it. We're not using it. We've just defined it. So we have to go to our player controller that we made, because remember, the player controller is what's actually getting the input, and the pawn is being possessed by the controller. So let's go to the event graph here. And what we want to do is we want to set up the input. So we have this event begin play. And what I want to do is drag off of that, and we're going to do it's add map. Okay, so again, here. So sometimes if the thing that you want, like I want add mapping context, it's not showing up. I could turn off context sensitive and maybe find it, and I'm sure I could. But an easier way to do it is if you get data that is already going to use that thing, then it's better at kind of like guessing. So what I'm going to do here is I'm going to get a reference to self. So I can just right click and say self. And self is referring to the player controller itself because we're in the player controller. I'm going to drag off of that and do add enhanced. Actually, I want this one. Get enhanced input local player subsystem. And then we're going to drag off of that. And now, if I do add mapping context, it's like, oh yeah, I know what you're talking about. And then let's connect those up, just like that. And now here it's asking us, okay, like what mapping context do you want to use? So let's open up our content drawer. And then this time, I'm going to right click and we're going to go to input and we're going to go to input action. And I'm going to call it IA underscore fire laser. You don't have to call it fire laser. I just wanted to make it clear that it does not have to have the same name as the method that you're going to use it for. So we'll open it up. As you can see, here it is. This is our input action. And so we don't really need to worry about the top stuff. However, we do need to worry about what actually triggers this input. So we are going to click this little plus button to add an element. And you can see we have different things. So like there's tapping, holding it down, hold and release. There's a bunch of different things. And so I just want it to be when you press it, it happens immediately. So you can see the pressed one says fires only once when the input exceeds the actuation threshold, which is just a single click, counts as one trigger of this action. That's it. The next thing we have to do is we have to add a mapping context. So open up our blueprints folder again, right click, go to input, and we're going to do input mapping context. And I'm going to call this IMC, the default layout. So what these mapping contexts are, so let's say you have a game where, I don't know, it's like a first-person shooter, your player's running around and stuff, and when they get in a vehicle, you want all of their controller schemes to change. This is how you would do that. So you'd have all of the like on-foot controls in one context, all the vehicle controls in another context, all the, I don't know, swimming controls in another context. So we're just going to have one, so I just called it default. So let's double click on that to open it up. And you can see up at the top, it's like, okay, what mappings do you want to add to this? I'm going to click the little plus, drop down, and then I'm going to make sure that fire laser is one of the input actions associated with this layout. And then now it's asking me what key I want to use. So I'm just going to click the little picture of the keyboard and then hit spacebar, and you can see it automatically did it. And we can add more. So I'm going to click here to add another control binding, click the little keyboard, and then I'm going to left click. And so now I'll give you guys a second to look at this. So the mapping is our IA fire laser, and I added two specific control bindings, and one of them is spacebar and one of them is left mouse button. And literally that's all you have to do, because we already said how it's triggered over here in the input action itself. So I'm going to hit Shift Control S and save everything. And in fact, I'm actually just going to close those. We're not going to need them again. So we're going to go back to our player controller. And in this add mapping context, now that we've made one, let's click that drop down and we're going to select this default layout like that. Make sure you hit compile. Let's go back to our player pawn. Add an event for this IA fire laser. And you want the one with the arrow next to it, not the other one. So I'll put that like that. And so this is just saying, okay, whenever this action that we defined is triggered, what happens? And so we'll fire the laser. So basically how it works is we have this fire laser input action defined. We can make it do anything we want. And then in the context, we said that spacebar and left click are what trigger this. And so here in the player pawn themselves, we're just saying when this is triggered, call your own fire laser event. So I'm going to hit compile. Now let's hit play, and I can shoot lasers. So I can shoot lasers with left click, and I can shoot lasers with spacebar. So now that we have a player that can shoot lasers, of course, the next thing that we need is an enemy. So let's open up our content drawer, and you probably guessed what we're going to do. We're going to right click, go to blueprint class, and then we are going to make an enemy. So I'm going to make this one a pawn because it is going to be something that's possessed by something. In this case, it's being possessed by the enemy. So I'm going to choose pawn. You could choose actor as well, but if it's like something that's going to have like AI, loosely speaking, or like control from a human player, I always choose pawn or character. So let's do pawn, BP underscore, and we're going to do enemy pawn. Let's go ahead and open it up. I'm going to open up my content drawer, go to my textures folder, and I have this red enemy. So I'm just going to drag the red enemy sprite in there like that. And I'm going to, select the sprite here at the top. Let's make sure that he's at 0, 0, 0 for the position. And for the rotation, I want to do 0, 0, and -90 like that. And so he's going to be facing down like that. He's not going to be facing up, the player. So that's why we use -90. So he's going to be like that. And again, just like the laser moves up at a set constant speed. Our enemy is going to move down at a set constant speed. So over here, I'm going to add a variable, call it speed, change it from a Boolean to a float. We're going to jump into the event graph here. We can get rid of all of that. And then we're going to do the same thing. So we're going to drag out speed. I used control to drag out the get command for speed. I'm going to drag off of speed, hit the multiplication symbol, add this multiply node, connect that with delta seconds, just like that. It doesn't matter which one goes in which pin. And then I'm going to do this add actor world offset again, just like that. And of course, our enemy is going to be moving in the Z location, just like our laser, except instead of moving up, I want the enemies to move down. So for delta location, let's hit split struct pin so we can see just the individual ones. And I don't want to have to mess with making this speed a negative number. So what I'm going to do is I'm just going to drag off of this output for the first multiplication, do another multiplication, and then here in the bottom, I'm just going to type in -1. So we're just going to multiply the speed by -1, and then feed that into delta location Z here, and that will make our enemy move down as opposed to moving up like the laser was. Hit compile. Now we can click on speed and give it a default value over here on the side. So 1000 for the laser was pretty fast. Let's do like 500 for the enemies just for now. And I'm going to hit compile. And then let's go to our content drawer. Let's find an enemy. And let's drag the blueprint for the enemy out into the scene. So here's our enemy pawn. And again, he might be drawn in front of the background. He might be behind the background. We don't really know. So I'm actually going to go back to his blueprint, click on the sprite, go over here to rendering, go down, make sure the advanced drop down is down, and then in this translucency sort priority. And remember, if you ever have trouble finding it, just start typing it up in the search bar and you'll find it. So our background was at -10, so it's always going to be in the back. So 0 for the enemy should be fine. We shouldn't have to mess with that. So his location's at like -32,000 something. So there we go. I put him to 00800. Let's hit play. And now he moves down. And of course, you can shoot lasers. They don't damage the enemy yet. We're going to have to add in not only collision, but we're also going to have to add in actually doing something when the laser collides with an enemy. So now that that's all working, make sure to save, Shift Control S. We've got our enemy. Okay, so before we handle laser collision and destroying the enemy and stuff, something that I want to do is I want the enemies to spawn at runtime. I do not want to place them manually in the world like this. That would be kind of dumb. I'd have to place them all by hand, and then they'd all run down the screen once, and then that would be the end of it. So I don't want to do that. I want them to spawn. So we have a few options. Like, do we want them to spawn every, X seconds? Do we want them to, like, every time a player kills one, 2 more spawn, and then, if you kill another one, then 3 spawn? There's a lot of different ways we can do it. I think one of the easier ways is just spawning an enemy every X seconds, basically. So for this, I actually want to make a spawner for the enemies. So I'm going to right click and go to Blueprint class. This is just going to be an actor. You're going to call it BP underscore enemy spawner, just like that. And let's open it up. And there's a lot of different ways we can do this. So we could put the spawner at a physical location in the world and have enemies spawn from where the spawner is. We could also have one spawner in the world anywhere, and then have a bunch of like invisible objects around that the spawner uses to spawn enemies at the locations of those invisible objects. But I think what I'm going to do is I'm going to make it so it doesn't matter where our spawner is. It's going to calculate where it can spawn enemies, and it's going to spawn them within a set location, set boundary on the screen. That way we don't have to worry about putting, 20 enemy spawners in the world or anything like that. We're going to have true randomness on where they spawn. So it's going to be procedurally generated, but we're going to have a constraint on there so they don't spawn in places we don't want them to spawn. So let's go to the event graph here for the spawner. And there's a few things we want to do first. I'm going to get these out of the way. So basically what I want to do is I want to make sure that they spawn. There's going to be a minimum distance to the left that they'll be allowed to spawn so that they're still on screen. And of course, there's going to be a maximum distance off to the right to make sure, again, that they're still on screen. So I'm just going to make those variables. So over on the side, remember, click the little plus button to make a new variable. And I'm just going to call this one like y min, and it's going to be a float. And then I'm going to give it another variable, and we're going to do y max. That's also going to be a float. Now, I also want to make sure that they always spawn up above like the view of the camera. So I'm going to make another variable, and this one is going to be called z spawn. And that's a float as well. And I don't really care how high, like the enemies are all going to spawn on the same Z position. The only thing that's going to be different is their left and right. So Z is just going to be a single number, and they're always going to spawn at that same Z. So now what we need to do is we need to actually figure out what are the bounds of the camera, like what position in the world is that far left, that far right, and the top of the camera, so we can make sure that they spawn inside the left and the right, but outside of the top, so the player doesn't see them just pop into the world and it looks like they actually fly down from the top of the screen. So basically we need to calculate all of these values. So I'm just for now gonna get rid of all of these. We might add one back later, but just to have a nice clean graph here. So we're gonna make a custom event. So type custom and click on this add custom event. And I'm gonna call this set viewport limits. And all this event's gonna do is do all of the math for us to figure out what these variable values need to be. So I also want this to have an input. So I'm going to select the event. And then over on the right in the details, there's this events tab. And I'm going to click the plus button, or sorry, input tab. I'm going to hit the plus button. And I want this to actually be camera. So I'm going to click the drop down for the type. And obviously it's not a Boolean. It's a camera. So I'm going to hit search, camera. And I think the one I want is camera component. And I want it to be an object reference. That means it's referring to a specific camera and not just the camera class in general. So again, that's camera component object reference. Make sure it's this blue one or it won't work. So there we go. So we have a new input here. So whenever this event's fired, we also have to tell it a specific camera, and that's going to be used in some of our calculations. So the first thing we need to do is figure out actually where our camera is in the world. So we're going to go back to our good old friend, the get world location node, and that's going to give us an XYZ coordinate of where the camera actually is. And the reason we need to know that is so that we can then translate into distances away from that center point of the camera once we calculate those. Remember, we set the ortho width earlier when we first made our camera. So that's another very helpful number. We can directly get what the width of the entire camera view is and do a little bit of math to figure out where we can place our enemies. So we're going to drag off of the camera and we're going to do get ortho width, just like that. And all that's going to do is return how wide in centimeters our entire horizontal camera view is. Now what we need to do is, if we're getting the location from the camera right in the middle of the screen and we know how wide the whole thing is, well, half of the width is how far we can go to the left and the right to get our minimum and our maximum Y values. So I'm going to drag off of ortho width, and we're going to add a multiplication node, and we're just going to multiply it by 0.5. So that is giving us the half width. And then I'm going to drag off of that. We're going to do another multiplication node. Now, down here where it is trying to multiply a float by another float, I do not want to do that. So I'm going to right click here and I'm going to change it to vector. I want to take a vector, and in this case, I'm just using the vector as a direction, and I'm going to multiply it by the result of taking this by half, and then move something from the center of the world location to the left by that certain amount. I hope that makes sense. We don't want to move it in the X. We don't want to move it in the Z. We want to move it in the Y. So I'm going to put a 1 there. And then I'm going to drag off of that and do a subtract node like that. I'm going to right click on the output and split that into its individual components. And then I'm going to take this world location and drag it, make sure that goes in the top, and then move this one to the bottom. So I'll try to talk through this and see if it makes any sense. So we're getting the location of the camera in the world. We're getting how wide the camera is. We're taking half of that, and then we are basically multiplying that in the left direction. And then we're taking, again, where the camera's from, and then from that location, we're subtracting this value in this direction. So that's going to get us a point that's all the way to the left, half of the width of the camera, which again is going to be the very left side of our screen. And so the next thing we want to do is, that's our answer. It's right here. It's the Y. So I'm going to drag off of that Y and I'm going to say set Y min. And that's our number. We've got our Y minimum. And in fact, before we forget, let's connect this execute pin right there. And now we also need to set Y max. And luckily, it's pretty easy to get to Y max from that. All we have to do is take what our Y minimum is, and we're going to use an add node. And what are we adding? We're actually adding this ortho width, so you can connect it like that. This is one of the worst things in a lot of people's opinions about blueprints, how messy this looks. And it does look messy with all the wires crisscrossing and everything. You either just get used to it or you hate it forever and it never gets better. So anyway, so now we know what the Y max is going to be because we had the Y min and we know the width of the camera and we just added it to it. So then we're going to come over here and we're going to do set Y max, just like that, and connect those execution pins. Now we have to find out what is a safe location in the Z-axis for them to spawn so they're up above the upper view of the camera. So we're going to put a brand new node in here that is called get viewport size. We're going to right click, split struct pin, so we get specifically the X and the Y. We don't really care about what the viewport size is. What we do care about, though, is the aspect ratio, because we cannot directly get the height of the camera like we can with the width. But if we know the width and we know the aspect ratio, then we can calculate the vertical distance of the camera. So we're going to do a division node here, and we're going to divide X by Y, and that's going to get us the aspect ratio of our screen. And then we're going to divide and make sure this is connected to the bottom one. So that's left control and drag. You can change which pin it goes to. And what we want this to connect to is our width again. And actually, I'll show you something cool. So instead of dragging all the way from the width again, let's just double click on this wire that's already going from the ortho width to our addition thing here. And you can then move around this node to like make things look a little neater and nicer. But what you can also do is drag off of that node like that. So the ortho width goes to here and then splits and goes to two different directions. That usually keeps things looking a little cleaner than just dragging it off over and over and over again. Okay, so we got our aspect ratio. Now we're dividing the width by the aspect ratio, which is going to give us the vertical distance of our entire camera. But we need to find out what half of that is. So we're just going to drag off of the output of this. We're going to do a multiply it by 0.5. And then we're going to do another multiplication like that. And we're going to right click on the bottom and change it to a vector, just like we did before. And this time we want to actually move up. So X is going to be 0, Y is 0, and Z is 1. So remember that represents our direction. And then this float that we're passing in and multiplying it by is going to represent our distance. So this is the distance, and then the direction is straight up because we have a 1 in the Z there. After we've got this here, we are going to use a addition one, move this one to the bottom like that. And then the top one that we're going to use is we are going to take this original get world location and drag it all the way over to connect to there. Because again, what we're doing is we're taking the center of the camera, which is the get world location. We've calculated how high half of the height is, and then we are going to add that to the center, which is going to move it upwards. And then that's actually going to be giving us our Z value. So I'm going to right click on this yellow output pin, split the struct pin, drag off from the 0 or the Z pin output, and then we're going to set Z spawn just like that. And then connect it. This should get us everything that we need and make sure that our enemies are spawning within a set zone. Okay, so hit compile just so we don't lose any of that. And now what we need to do is all this is doing is just calculating our view limits. That's it. It's not actually doing anything with them. So what I'm going to do is I'm going to make an event begin play node. It was there before, we deleted it. Let's add it back. And right when the game starts, I want to set the viewport limits. So I'm going to drag off of that and do set viewport limits. And it's asking me to give it a camera. I'm just going to leave that like that for now. And we'll come back to that. So the next thing I want to do is write the code for spawning the enemies, the spawner. So let's right click. We're going to do a new custom event. And by the way, all of these custom events could be functions. It's just for these particular ones, it doesn't really matter. So spawn enemy. Okay, remember we want to do the spawn actor from class node. And our class is going to be the BP enemy pawn that we made. And for our location, I'm going to right click on the spawn transform and split it so that we can see the X, Y, and Z the location, the rotation, and the scale separately. And then I'm going to right click again on the location and split that one so that we can see the X, Y, Z values individually. Now I'm going to drag out our Y min and our Y max variables, add a new node, random float in range, and this will randomly pick a number that's between the two input numbers. So we'll hook Y min up to the minimum, Y max up to the maximum, and then we'll feed this into the Y pin, and then we'll drag out our Z spawn variable and plug that into the Z. So now every time we spawn an enemy, it is going to randomly pick a point between our Y minimum and Y maximum, and then use our Z spawn so they're up off the top of the screen, and then it will spawn them. Now what we need to do to get this to actually work is, remember, we have to set the viewport limits and we have to do all those calculations, but it requires us to give it a camera so that it can then, get the width of a specific camera and its location in the world. Well, the camera is on our player, so we need to go back to our player. So let's hit compile here. Let's go back to our player pawn. And of course, our player has a camera. It's over here on the side. And what we're going to do is we want to make sure that this camera is a variable that we can actually use and pass on to other things. So see, we can do get camera here, and we can drag it out like this. And that is the component. But I want to save it as just a public variable that can be grabbed. So I'm going to create a new variable and call it player camera reference. And I'm going to make the type a camera component, make it an object reference. And then inside our player's begin play, after we do our get vertical position, we can just go ahead and set the player camera reference just like this. Now, it's possible that we might have been able to access this camera component directly, but I prefer to save it in a variable like this so that we have control over what can access it, when, and then we can also make it a instance editable if we wanted to change it, or later, I don't know if the player was switching between different cameras and stuff. So make sure you compile. Let's go back to our enemy spawner. And so we need to get a reference to the player's camera for our set viewport limits event here in begin play. So first thing we want to do is we need to get a reference to the player. So we can do get player pawn at index 0. So there's only one player in the game. So player index 0 is going to be the only player in the game. Now, we can't just drag off of this and say, grab the camera, because Unreal doesn't know if this player pawn is our player pawn class. It could be, a different class. So we need to check to make sure that it is our class. So there's this thing called casting, which is what we're going to do. So we're going to drag off of the return value, which represents a player pawn. And we're going to do cast to player pawn space like this. And so what this is saying is it's saying, okay, get the pawn that player 1 is controlling and then try to treat it like it is a BP player pawn space class. If it is, then we know that we can do stuff with it. So I'm going to say if that succeeds, then we're going to continue on. If it fails, then that would mean that the player pawn that got casted in here is not our class. So, but we know it will be. And then so now though, we have this reference here that we can drag out and we can say get player camera reference like that, and then hook it up. So in our enemy spawner, we're going to grab the player pawn, check to make sure it's the right type of player pawn. Once we know that it is, then we can access that camera reference, and then we can plug that in here to our set viewport limits, that specific camera, so that we know we're using the right camera to do all that stuff. Now, before we test this, there's one thing I think might be a problem, and that is what happens if this player camera reference has not been set yet and this runs. So this might not be necessary, but I want to show it anyway. Let's go back to the player pawn, and instead of doing this in our event graph for begin play, I'm just going to grab that camera there and grab this, and I'm going to just copy those and then delete them. And then this time we're actually going to go to the construction script and paste those in like this. The construction script is pretty cool. It actually runs before begin play from the event graph. So this will make sure that when the game starts, our player's camera reference is set before the spawner tries to access it. Now, the construction script is also pretty cool because it will run this in the editor and when you play the game. Meaning, if we were to go to the main map and drag a new player into the game, it will actually run this code before we even hit play. And then it runs all of this again when we do hit play. So you can use this for you drag a tree into the editor and then it runs a bunch of code that randomly generates a forest or something like that. So construction scripts are pretty cool, and that's what they're for. So I think we have everything set up. Let's give it a try. Let's go back to our map. Remember, before we do anything, let's delete that enemy that's already in the world. Let's find our spawner. So here's our enemy spawner, and let's just put it in the world. It does not matter where it goes because it's not spawning them at its location. It's calculating based on the camera and doing it like that. So I'm going to hit play, and I realized I forgot something stupid. Okay, so so back in the enemy spawner, we got the camera, we found out all the limits, but the thing that we haven't done is actually spawned any enemies. We have all the code here for doing it, we just haven't actually called it. So there's a lot of ways to do what I'm about to do. This is maybe not the best way to do it, but it does work. So we're going to drag off after we get these viewport limits in from event begin play in the enemy spawner. Let's drag off of this, and we're actually going to just directly right here call spawn enemy. Then what we're going to do is, because I don't want to hard code this, I want to make another variable. So I'm going to go over to the left here, make a new variable. I'm going to call it spawn delay. It is going to be a float. I'm going to hold down Control and drag it out, or drag it out and click Get, whichever one you prefer. And then I'm going to drag off the output pin for spawn enemy and use this node called delay. What this will do is it will actually wait for the specified number of seconds and then continue on. You can use these delays in events. You can use them in macros, but you cannot use them in functions. So if you did want to, I don't know, collapse some of this into a function, you can't use delays, but you can in events. So this is fine. And then we're going to connect our spawn delay right there. So that's how long it's going to wait. I'm going to hit compile really quick, select that spawn delay variable, and we're going to give it a default value of, let's say 2. So every 2 seconds, so it's going to spawn an enemy and then it's going to wait 2 seconds. And then here's the kind of like silly thing that we can do. We can drag off of complete and actually hook it back to the beginning of spawn enemy. I like to double click on these to make it look a little prettier so that I have a couple extra handles to move around so it's easier to see that you're doing that. So yes, this looks dumb, but it will work. The game's going to start. It's going to calculate our spawn limits. It's going to spawn an enemy using those calculated things. It's going to wait 2 seconds, and then it's going to jump back, spawn another enemy, wait 2 seconds. So this is just an endless loop of enemy spawning, basically. So I'm going to hit compile. Now let's jump back into our game and hit play and see if it works. I don't see any enemies. Let's see. Okay. So let's find out why that didn't work. We have our enemy spawner here. It's way in the back, but that shouldn't matter. It wasn't even spawning any enemies. So let's just make sure. Event begin play. Also, I just want to say the reason that I'm doing this live and not editing out any mistakes and stuff is because one of the biggest problems I see students have is that if there's a mistake, they just don't know how to fix it and they just completely get stuck. So I like showing when I make mistakes because I also want to show how I do my debugging to find out when something's not working, why it's not working. So let's do a few things. This is the easiest way to do debugging here. The first thing I'm going to do is we're going to come down here to this set viewport limits. And at the very end, I'm going to drag off from this last set thing and do a print string. And I'm just going to say limits calculated. And then I'm going to compile and let's go back. So if I hit play and we get that print off, limits calculated, that means at least that part is working. So we know that's working. So the limits are being calculated. And so now let's go in here. And what I want to do is let's make sure that this is actually working. So I'm going to drag off of this cast2 BP player pawn space, print string, and I'm going to say, let's see, player is, correct. So if this doesn't work, if this doesn't print off, that means we know that the player pawn that it's finding is not actually the right player pawn. So let's hit play. Okay, limits calculated, player is correct. Those both printed off. So we know that's right. So I can delete that, connect those up directly. And then now here's where we don't know if spawn enemy is actually happening. So here in our spawn enemy event, at the end after an enemy spawns, which is not happening for some reason, let's make sure that we set this string to say enemy spawned. And obviously they're not spawning, or they're spawning and instantly dying. I actually think I see the problem already, but I'll kind of keep going step by step with how I'd solve this. So hit play. So it did say enemy spawned, but there was no enemy spawn. So I think one problem might be this collision handling override. I think when the enemy spawns, it's actually hitting the background and counting as a collision and not actually following through with the spawn. So it's just not spawning it, but it's still making it to this print string. So for this collision handling override, I'm going to select always spawn, ignore collisions. Hit compile, go back, and now the enemies are spawning. So there we go. Every 2 seconds, we have an enemy spawning. So I've noticed, at least at one part, we've got some of our math wrong because these enemies are spawning, on the screen. They should be spawning off the top of the screen. But we'll come back to that in a little bit and see if we can make that work better. So the next thing, though, I just want to keep pushing forward. Let's do making the lasers actually collide with the enemies so that something happens. So basically how collisions work in Unreal is that there's a few different things you can do. So there's overlaps, which means that they don't physically block each other from touching, but it does calculate that they've intersected each other. And then, of course, there's physical blocking where they actually block each other's movement. And then, of course, you can also set them to be physics objects where one will actually knock the other one out of the way. This is just a simple 2D game. I just want it to sense the overlap, and that's it. So the first thing I'm going to do is I'm going to go into my laser here and my laser blueprint, and I'm going to click on the sprite for the laser and scroll down a little bit. And you can see here, there's a collision tab, and there's a collision preset right here that says block all dynamic. I'm going to change that to overlap all. And the other thing we need to make sure is that we have this generate overlap events thing is actually checked. Then what we need to do is we're going to make an event, and it's not a custom event. It's one that already exists. It's actor begin overlap. And what this does is it's an event that, probably guessed it right, whenever an overlap is detected, it will do whatever we tell it to do. So let's just, again, our good old debugging friend print string here, and we're just going to say collision detected for right now and hit compile. So let's go back in. I'm going to shoot my laser, and you can see it's actually like several collisions. So it's, when I'm shooting it, it is overlapping with the player themselves and actually counting that as a collision. But now when it hits an enemy, it is also registering that collision. So now we know that the collisions are actually being seen and that they're actually happening. Now we just have to go back to our laser and then add some code to actually make something happen. Now, I don't know if you guys noticed, but when we were shooting those lasers, every time we shot one laser, it was printing off 3 collision detections. So the first thing it was colliding with was the player. The second thing it was colliding with is actually the background. And then the third thing it was colliding with is an enemy. So fixing the background is really easy. Let's go back to our main map. Let's click on our background, and we are just going to go down to here to where it says generate overlap events, and we're going to uncheck that. That's it. So I'm going to play again really quick just to test. And so now we're only getting 2 messages, one for when it intersects the player, and then one for when it intersects the enemy. Now, I just want to say that there is a way to make it so the laser will will collide or overlap with the enemy, but not the player. But that's a little beyond the scope of this tutorial. We're just going to do it a different way. And the way I have decided to do it is we are going to, instead of have the laser print something off when it intersects anything, we're actually going to move this code to the enemy. So I'm going to copy these 2 nodes here and delete them from the laser. I'm going to hit compile. Let's go to the enemy. Click on the sprite. Just double check. We need to make sure that its collision is set up right. So the collision for the enemy right now is block all dynamic. I'm going to change that to overlap all and make sure that generate overlap events is on. And then let's paste that code and hit compile. Let's go back here and hit play. Now when I shoot my laser, you can see that it's printing off a message only when it hits the enemy, because now all of our collision, I was going to say collision code, but this single print string is now only running on the enemy side. So we're going to start with something really, really simple, which is just whenever the enemy hits something, it basically destroys itself. So I'm going to get rid of this print string because we know that's working. And the node is called destroy actor. And you can see the default target is self. So this means the enemy is just going to blow himself up. So let's just do this first. Hit compile, connect those together. And then when we hit play and we hit the enemy with a laser, they die because they're destroying themselves. I want the laser to get destroyed as well. So the laser is actually represented by this reference here. So whenever there's an actor begin overlap, it automatically grabs a reference to the actor that hit it. So what we actually want to do is add another destroy actor. And what I want to do is actually like this. So the first thing we're going to do is we're going to destroy the thing that hit us, and then we're going to destroy ourselves. So the enemy is going to die after the laser dies. Let's hit compile, go back, we shoot a laser. Now they both die. The laser and the enemy are both getting destroyed at the same time. Cool. That's what we want. Okay, so now, what is a game without keeping score? So the first thing we want to do is, before we get to the UI, is like, where are we actually going to keep score and how are we actually going to keep score? So remember earlier I talked about the game state is a special blueprint class that is replicated to all players. So if this eventually was multiplayer, that's where like the total score would be kept. For this particular game, since it's a single player game, we could technically keep score. We could keep score in the player controller. We could keep score in the enemy spawner. We could keep score on the player pawn. But let's kind of do it the right way and do it in a game state. So right click, blueprint class. And you notice it's not on here. So we're going to hit this little drop down that says all classes. And I'm going to search for game state. And we're going to use this top one. The bottom one is a more complicated one for multiplayer games. We're just going to use this top one, which will work in multiplayer, but it doesn't have as many of like extra features that we don't need. So game state base, that's what we're going to make. Hit select, and I'm going to call this BP underscore game state space. And let's open that up. So first thing in here is, well, obviously we want the player to get points whenever an enemy is destroyed. And of course, in the end, we want that to be displayed on a nice user interface so they know how many points they have. But to begin with, we actually just need place to store this. So we're going to make a variable, and I'm just going to call it score, and we're going to make it an integer. And that's really all the data that we need as far as keeping the score. We don't have any other data. Now, of course, you could easily expand this to being, it keeps track of how many waves you've destroyed, or it individually keeps track of how many enemies you destroyed, and then they spawn faster, or they take 2 hits to kill. You know, there's a lot of extra stuff you could do. But right now, we're just going to keep track of the score. So before we go further, we just made this new game state. So save everything, compile it, and I actually need to go back to this BP underscore game mode. Remember that we made kind of towards the beginning, where we set the new default pawn class to be the one we made, and we set the player controller to be the one we made. Now we need to change this game state class from using the default game state base to using our BP game state space, and hit compile. That way it knows when the game starts to spawn an instance of our game state, not just generic one. So that way we actually have access to everything. So we have our score variable, and obviously we're going to need to write some code to increase the score, but we need to think about how and where we're going to do that. So right now we have the enemies being responsible for destroying themselves and the laser. So it kind of makes sense right now for the enemy to be the one that tells the game state, like, hey, I just died. You need to add some points. So That means the enemies need to have access to the game state. So let's go to the enemy pawn class, and super easy. All we have to do is at the beginning, we're going to add a new node here, and the node is get game state. And remember, there's only one, and it's replicated to everybody, so there's only one game state. And then we're going to drag off of that, and we're going to do cast to game state space, just like that. There is no event begin play here in the enemy, so we can add one. Event begin play, because we only want this to happen once, right when the game starts. So we can do that. And the easiest thing to do here is, instead of doing this every single time we need to like increase score or whatever, I'm actually going to just right click on this as BP game state space and promote to variable. And I'm going to call it current game state, just like that. And you can see it automatically made us a set node for that new variable. It automatically created the variable, made it the right type, and connected everything up. And the reason we did that is just so if this enemy event graph ever does expand and get pretty complicated, we don't have to do get game state cast to every single time. We can just reference this one variable easily just one time. So now that we have a reference to it, let's go ahead and compile. Let's go back to the game state, because we need to create an event in here that handles actually, working with the score. So let's just do something super simple. Let's make a custom event. I'm just going to call this increase score, nothing fancy. And really all we want it to do is increase the score. That's it. So I am going to make it have an input. So remember, click on the event over on the right, click the plus button, and it's going to be an integer. And I'm just going to call it point value, so that whenever anything calls increase score, it can, put in its own number for how much it's supposed to be worth. And then we are going to drag out score with Alt to do set. But I also want to drag out score and use get as well. And I also want to drag out make an addition. So whenever the score gets increased, what we want to do is we want to add together the new points that are being passed in to the old score, and then the result of that is going to be set as the new value of that score variable. So this is the most simple score increase thing we could do, other than just making it go up 1 point every single time. So I'm going to hit compile right here just for debugging purposes. Let's drag off at the end of this, and we're going to do print string. And here's something pretty cool. We can just drag the output of this, and it will automatically convert that integer into a string. So it'll print out how many points we have. Hit compile. Let's go back to our enemy pawn. And right here, before the enemy destroys itself, we are going to drag in a get for our current game state. And we are going to call the increase score event. And here it is asking for a point value. So we could just put in 5 there. We could put in 10. We could put in whatever. But, the better practice is making variables. So I'm going to make a new variable. Call it point value. Make sure it's an integer. Drag that out. Get point value and connect it just like that. So here's our connected graph. I'm going to hit compile. Select point value. You can't set the default value until you hit compile. So And then I'm going to set the default value. Let's just do 10. And then I'm going to hit compile again. And now, unless I missed something stupid, let's check, go back to the main map. Let's hit play. And there we go. So every time I shoot an enemy, you can see in the upper left where the print string messages show up, my score is being printed off with the new value, and it's going up by 10 every time I destroy an enemy. So that is working. And the next thing we have to do is actually do the UI stuff. So let's go back to our blueprints folder. I'm going to right click, and you're going to go to user interface, and we're going to select widget blueprint. And then we're going to use this top one that just is called user widget. I'm going to call it WBP for widget blueprint. And I'm just going to call it main UI. And then we're going to double click it to open it up. As you can see, we're presented with something that kind of looks like the rest of everything we've seen in Unreal so far, but also there's some stuff that's quite drastically different. So on the left over here, we have all of the different things that we can add on to a UI. In the middle here, we have a representation of what our screen is going to look like. So on the left, I'm going to search at the top. They call these palettes. They're things you can add to the UI. So I'm going to look for a canvas panel. If you use Unity, you're probably familiar. They call it a canvas as well. And so this represents our actual screen. Okay, so we have our canvas panel. Think of that as the main, like you have to have this, and everything you put is going to be a child of this canvas panel. This is our screen. So on this, what we want is, I just want right now, super simple, just display the score. So under here, under the common tab, or you can just search for it, there's a text. I'm just going to drag that down and drop it on top of where it says canvas panel down here in the hierarchy. And I'm going to give it a name up in the upper right here on the details. I'm going to call this score text. Now, there's a lot of different ways we could do this. We could make the actual text of this say something like score, and then, whatever the score is. And then every time our score changes, we basically literally just write, score, and then, the new number or whatever. But I actually want to make these two different text objects. So I'm going to make the first one just say score, just like that. And I'll show you some positioning tricks. So I want to anchor it up in the corner, which it looks like it already is, but if it wasn't, I'll show you what you do. So over on the details, you click this drop down for anchors, and you can see all these default locations. So I'm going to hold Shift and Control and click on this upper left corner one. Holding Shift aligns it up at the top, and holding Control updates it. So there we go. It already was, but that's what would happen if it wasn't. That's how you do it. So now this position X and position Y are relative to our anchor in the upper left corner. The reason I like doing that is so then it's really easy to just give it some padding. So position X, I'll do 10, and position Y, I'll do 10. So there it's not, crunched up in the, in the corner. Now I want to add another text object. And this one is going to be the one that I want to actually keep track of the numerical score. So I'm going to call this one the score value text, just so I don't get them mixed up. And here we go. So our score value text, I'm going to make sure that it is also anchored in the same place, which it looks like it is. So I can make the position Y 10, so we know they're lined up perfectly. Let's just kind of mess with this position X until it looks good. And I'm going to actually change the content text here to be a number. So let's just make it 0, because that's obviously our default starting score. And let's move it over a little bit, maybe a little bit more. Okay, that looks good enough. Yeah, it looks good enough. Okay, so now the next thing, I actually want to be able to access this 0 at runtime when the game's running. So select that 0 over here in the hierarchy, or you can click on it here in the viewport. Up at the top of your details panel, there's this little button that says is variable, and you want to click that and make sure it's checked. What that does is it tells Unreal that this is a variable that we can then access and change and modify, stuff like that. So up at the top, whenever you're working in these widget blueprints, there's a designer tab and there's a graph tab, and they call them modes. So if we click on graph mode, we basically get what we're used to seeing already, which is this blueprint, style event graph. The only difference is it has some different events, like event construct is pretty much the same as the event begin play for the stuff that we've seen before. The UI stuff just calls them, things a little bit different. There's a lot of different ways we can update this 0. We could make a method or an event inside here that then gets called from the enemy or from the game state whenever we want to change things. That is sort of the way you would do it in Unity and a lot of other game engines. So I'm going to show that first, and then I'm going to show a better way that is unique to Unreal. So first thing I'm going to do is inside this event graph, I'm going to right click and we're going to do a custom event. And I'm going to call this one update score text. This is going to be the name of our event. And all we want this to do is we basically want this to have an input. So I'm going to select it. Now the details is over on the left. I'm going to click the inputs button and I'm going to give it an input called new score, and I'm going to make sure that it's an integer. I chose to make score and my number 2 separate things. If you chose to make it just score with a colon, a space, and then a number, I'll show you how to do both ways. So if you have them both separate, then what you need to do is you need a string append node. For the first thing, you'd put score, colon, make sure you put space, and then for B, you would put the number. So what that will do is it will make a string that starts with, this is, concatenation. If you've used any other sort of programming, this will be familiar to you. It's the same thing as saying like score.text is equal to score plus, and then the number. That's all that is. It just appends them together. And then over here, you can see we have this score value text. We're going to get the score value text. And if you don't see that, go back and make sure that you click is variable. If you don't do that, you won't see it here in the graph. And then we're going to drag off of that and we're going to do set text, and it's down at the bottom. It's this set text like that. And again, it's confusing. There's a few different nodes called set text, so make sure it's the right one. This is what it looks like. Connect that. Okay. And then it's asking, what do you want the text to be? This is technically not a text, it's a string, but we can just connect the string to the text and it will automatically convert the string to text and work just fine, like that. Now, this is what you would do if you did not make 2 text objects. I did make 2 separate text objects, so I don't need the append, and I don't need that, and I don't need that. And all I have to do is do this. Because my score text is always going to say score, and I have a individual separate text object that is literally just for the number. So mine's going to look like that. Okay. Now, again, another part of the headache of Unreal UI is we have to actually create the UI in the game. So I'm going to do this in the game state. It's just an easy place to do it. So I'm going to go back to the game state. And then in here, we need to initialize the UI. So I'm going to do an event begin play. So we just want this to happen once right when the game starts. And I want to get the player controller. And a UI is unique to a specific player controller. So we're getting the player controller for player controller 1. I'm going to drag off of it. And we're going to do create widget. That. And then it's asking for the class. And we want to use our one that we made, which I called mine main UI. Connect that up. And that's going to create our UI widget. But it's not actually going to show it on the screen. So now what we need to do is we need to drag off of, and actually I'm going to right click on this return value and promote it to a variable. And I'm just going to call it main UI. That way, if we ever need to reference it again, we have a variable. We don't have to go through all of these steps again. Then I'm going to drag off of here and I'm going to say add to viewport. And so now that UI will actually show up. I'm going to hit compile and I'm going to go ahead and play. Let's just make sure it actually works. So yep, you can see in the upper left, we have score. Obviously that 0 is not updating because we're never calling the method to actually update it, but you can see that our UI is working. So I'm going to go back to our enemy pawn before I forget. Or sorry, it's in game state. Go back to game state and I'm going to get rid of this print string because we know that the score is working. We don't need to verify that anymore. We do need to do though, is we need to make sure that when an enemy is destroyed, it actually calls our update score text event that we have on our UI widget. And I'm just going to do that in the game state. After we've increased the score and set the score, then I'm going to get a reference to this main UI, which we, grab the reference to up here. And then I'm going to call the update score text event from that main UI. And it's asking, what's the new score going to be? And we'll just drag it off like that. So it will pass that value into here. And now, because increased score is already getting called by the enemy when they die, it should follow through and update the UI. So let's check. So there we go. So now, as we destroy the enemy ships, you can see that our score is going up and it is actually reflected on the UI, which is a huge accomplishment. So now the player actually knows how many points they have. And next, I would like to show the the cool Unreal way to do this. So basically, the other way to do this is instead of having this event that is being called here, we are going to directly bind this score variable to the UI object. So we have to go back to the game state and this score, we have to click on that little eyeball to make sure it's open. Again, you can also, over here in the details, just check this instance editable box. And then after we do that, make sure you compile. We are going to go back to our widget blueprint. And then right here in event construct, which again is basically like event begin play. It just happens right at the beginning whenever this UI is actually made. And what I want to do here is I want to do get game state, just like that. And then we'll drag off. We need to make sure it's the right game state. So we're going to do this other cast to game state space, just like that. And then what we want to do is, again, we don't have to, but I kind of want to save it as a variable. So I'm going to right click, promote to variable. I'm just going to call it current game state. It'll automatically do that for us. Now we have a reference to it, which means now that we have a reference to it, we can use it. So after you've done all that, hit compile, and we're going to go back to the designer. We're going to click on this number here. And so for this to work, you have to have these two separate things, the score as one text and then the number as the second. But all we have to do is over here where we have the text where I can, right here, change it to a 5 or a 10 or whatever. Next to it, there's this little like link. This is the binding button. So we're going to click that, hover over current game state, and then select score. And then hit compile. So what that's doing is it's saying that we want to bind the value of this to match the score from the current game state. So that's why we had to, here in the graph, grab a reference to the game state so that we can actually access it. And that's also why on the game state, we had to make the score public so that it can be bound to. So just to prove to you that that's working, I'm actually going to go back here to the main UI, and you don't have to do this. I'm going to delete that method. I'm going to go back here, and you can see now this is all like red because this method doesn't exist anymore. I'm going to delete all that. And so now you can see nothing is calling that method that doesn't exist anymore. So if our UI updates correctly, it's purely because we did that binding thing. And as you can see, it is working. That number is just directly bound to that. So it will always match whatever that score is showing. Okay, so there's one other problem. So I'm going to let an enemy run into me here. So the enemy ran into me. And remember what our code does is when the enemy runs into you, they destroy themselves, but they also destroy the thing that they touched. So obviously, we want them to destroy the laser and destroy themselves when they touch the laser, but we do not want them to instantly kill the player. You also notice that when the player gets hit by the enemy, it destroys the camera as well. So then the camera just kind of goes all crazy and we lose control. So we need to make sure that the death of the player is handled a little more elegantly and does actually what we want. Now that I'm thinking about it, I kind of like that when the player dies, the camera gets destroyed and like zooms in really far, and then the background like gets really bright. I mean, I don't know. I think it looks kind of cool. If you didn't want that to happen, what you'd have to do is we'd have to write some logic for, if the enemy touches the player, instead of destroying the player, it would instead just make the player's sprite invisible and disable being able to shoot the laser or whatever, and it wouldn't destroy the camera. But honestly, I think it looks kind of cool, and it doesn't really matter anyway, because what I want to do is whenever the player is destroyed, I want it to show a game over screen. So the first thing we have to do is we have to go back to our enemy pawn. And right now, again, this code just isn't going to work. This is when you overlap with anything, destroy it, gain points, and then destroy yourself. So we definitely don't want the enemy to, or we don't want the player to get points when the enemy kills them. So obviously that's one thing we're going to have to change. So no matter what we do, we're going to have to make sure that we can tell when the enemy hits something if it hit a player or if it hit a laser. So that's something that we're going to have to change here to make sure it takes into account that. Before I do that though, let's handle the game over screen really quick. And so the first thing I'm going to do before I jump out of jump into the actual UI stuff is I'm going to go back to the game state. And now that we're in the game state, I'm going to make a new variable, and I'm going to call it is game over with a question mark. And I'm going to make it a Boolean. And this will just be one extra thing that when the game does end, we can, set that to true. So I am going to make a new custom event here called game over. And right now, simply the only thing it's going to do is whenever game over is triggered, it's going to set is game over to true. We'll use that somewhere else later, but right now it's just going to flip that and then not do much else. So let's go to back to the UI. Okay. And let's go to the designer. And all I want to do right now is I'm going to add another text object on the canvas panel. I'm going to go to the anchors. I'm going to hold down Shift and Control and click in this middle button. So now I'm going to take this. Let's make it under appearance. There's the font drop down. Let's make it like 50 is still kind of small. Well, we'll figure it out. So I'm going to type in here game over, just like that. And then again, the scale that it's going to be on the screen matches what this canvas is. So I do think that is a little too small. So let's do like 100. That's better. And then make sure that it fits in here so sizing and stuff works. I'm going to click on anchors again, hold down Shift and Control, click in the middle, and there it's perfectly centered. So game over is going to show up right in the middle of the screen. Now, obviously when the game starts, we don't want game over to be plastered in the middle of the screen, which right now it will be. So I'm going to select this text object and we're going to scroll down over here in the details. And there's this one here that says visibility, visible. We're going to set it to hidden. So when the game starts, game over is not even going to be visible. It's going to be completely invisible. Let's go back to the graph. And now I want to do another custom event. And I'm going to call this one show game over UI. And something I forgot to do, go back to the designer and we have to select this game over thing. And up at the top, we have to click is variable. And I'm also going to name it game over text, hit compile, go back to the graph. And now over here on the graph, you can see we have this game over text as a variable that we can access. So I'm going to drag it out, do get game over text. And then what I want to do is I want to change the visibility. So we're going to do set visibility like that, connect them up. And of course, it's going to make it visible. And I'm going to compile that. And that's it. So now what we need to do is actually call this whenever we end the game. So we're going to go back to game state. And remember, we already have this game over that we just made, and it's setting game over to true. The next thing that we want to do is actually show game over. So we're going to bring out get main UI, drag off like this, and then we're going to call show game over UI, just like that. And connect those up. And now that whenever the game over is triggered, it's going to set that to true, which again, we're not really using that yet. And it's going to access our UI and it's going to make sure that that becomes visible. So we still haven't ever actually triggered this game over yet. So let's go ahead and hit compile. I'm going to hit Shift Control S and save everything just in case. So let's go back to the enemy. So the enemy is right now what is handling overlapping with anything and then doing something. So obviously we still want it to continue to destroy the laser and destroy itself and give points. But if it hits the player now, we want to make sure that it actually ends the game. So up here, we already have this cast to the current game state. So that's something that obviously we've already accessed because we're increasing the score and all that kind of stuff. So what we want to do is basically we want to check whenever there is a collision, we need to make sure that it has actually hit a laser or the player and respond differently. So first, before we start doing anything there, let's go back to the player pawn and we're going to go to class defaults. And over here in the details, I would just search for it, search for the word tag. And you can see here where it says tags 0. So it doesn't have any tags. I'm going to hit add element and I'm going to type player with an uppercase. Doesn't really matter if it's uppercase or not, just you have to remember what you choose. So I'm going to type player. So now our player blueprint has a tag on it called player. There's a ton of ways to figure out what the thing that the enemy hit is. In fact, one of the things that we've used a lot is this cast to. So we could have it overlap and do other actor and then be like cast to laser. And then if it's true, it runs all of this. And then if it's false, we can cast it to a player pawn. And then if it's true, we can destroy the player and show the game over screen and all that stuff. But I wanted to use this opportunity to show you the power of tags. So again, the player pawn is now tagged with player. So we can go back to our enemy. And what we can do now is we can drag off of this actor. Again, remember representing the thing that it overlapped with. And we can say actor has tag. Now, the tags are an array. Any object can have as many tags as you want. We just have one. You can also check like which thing in the array is what tag, but this will search through all of them. And the tag, this is where we have to be careful, type it in exactly the same. So I'll double check. So player with an uppercase P, over here, player with an uppercase P. So they match. Okay, and now is where we're going to do some stuff. So this is going to output a true or false Boolean. Does it have that tag, yes or no? So we're going to drag off of the Boolean and we're going to add a branch. This is what Unreal calls like an if statement, basically. So this is just a conditional statement. Every other programming language usually calls this an if statement. Unreal, it's a branch. So instead of immediately doing all this stuff, we're actually going to go to this branch first. And so again, we're going to check to see if the thing that got hit has this player tag. If they do have the player tag, we need to obviously treat it like the player. So this is going to be a messy graph. We'll clean it up after. So we're going to go to the current game state and we're going to actually do game over. So we're going to call that game over event if it was true that the thing that hit the enemy has a player tag. So branch, if the result of this output is true, then we're going to trigger the game over. Okay, and then after the game over is triggered, we can actually destroy the player. So we already have that node right here. So we'll go up to here, we'll destroy the player, and then the last thing after that, I'm just going to disconnect these and get this out of the way for the time being. And then after that, we're going to destroy the enemy that hit the player. Now notice our increased score has been disconnected from everything. And right now our logic is basically only going to do, hey, did you hit the player? If you did, trigger the game over, destroy the player, destroy the enemy. It's not taking into account now anything about it hit a laser. So we know in our game, at least, the only other thing that exists is a laser. So we don't have to be like, did it hit a laser? We can just say if it's false. So if the thing that it hit does not have a player tag, then this branch is going to return false. And so what we can do from false is we can just go straight to increase score because we know that that means it hit a laser. And so after with false, if we just go straight to increasing the score, what we want to do after we increase the score is the exact same thing that we do after a game over, which is destroy it. So you can hook up multiple flow paths into the same thing. So just like that, just going to double check everything looks good. All of our logic makes sense. Yeah, that looks good. So let's compile that. Make sure we save, and let's play our game. Okay, so we can still shoot enemies. The lasers still work. That's good. Let's have one run into us and see what happens. Cool. Player dies, enemy dies. we did not get points for getting killed, and game over shows up in the middle of the screen. Cool. So the very last thing, and this game is finished, is I want to make it so after the player dies, they actually can restart and try again. So I'm going to make it a button press. And so let's go to the content drawer, and we're going to add another one of these input actions. So I'm going to right click, go to input, go to input action, and I'm going to call this one IA_restart. I'm going to open it up. For the trigger, I'm going to set it to pressed, just so it triggers one time on the frame that you actually press the button down. And then I can close that. We're never going to use it again. And I need to go back to our content drawer, and I need to open up this IMC default layout context mapping. So now we need to, and I'm going to just collapse all that. So we want to add a new mapping. And this new mapping down here is going to be for restart. And so for restart, I want to make it, I'm just going to make it enter on the keyboard. So I'm going to click the little keyboard button and then hit enter on my keyboard, and it'll automatically fill it in. And that's it. I don't have to give it any other behavior because we already have that being set in the input action itself. That's it. We can close this input mapping thing. And what that means now is we can go to the, let's do it in the player controller, since that's where we're handling, actually no, let's do it in the pawn. Or wait, no, sorry. We can't do it in the pawn, because if we do it in the pawn and you hit enter, it will restart the game as long as you're alive. But remember, after the player dies, they get completely deleted, which means all of this is deleted. So if we put the code for restarting in here, it won't work. So I'm going to put it in the player controller. So inside the player controller here, I am going to just right click, and we're going to do IA restart, just like that. So this is just saying, hey, whenever this gets triggered, which we said it's the enter button, then, you know, we're going to do some stuff. So whenever it is triggered, we are going to first, I want to make sure that the player cannot just restart the game whenever. I want them to only be able to restart the game if the game's actually ended. So that means we need to be able to check in the game state to see if that Boolean that we made, which is game over, is true. And only if that's true can we press enter to reload the game. And I'll show you really quick, if we don't do it like that, what will happen. So we can just drag right off of here, and we're going to use a node called get current level name, and that's just going to return a string of the actual name of the current level that we're in. And I can drag off of this, and we can do open level by name and just connect those together. So whenever we push this button that's associated with this action, which again we said was enter, we set up as enter, it's going to get the current name of the level that we're in and then pass that into open level by name and restart the level. So I'm going to hit compile. Let's go back in. Let's hit play. I'll show that this works. Let's kill a couple enemies. So our score is now 30. I'm going to press enter, and you can see it reloaded the game. My score went back down to 0, and it did reload. Again, I do not want that to happen just whenever. I want it to only be if the player has actually, you know, died. So the first thing that I need to do is we need to get a reference to the game state space so that we can actually see if the game has ended or not. So here in begin play, at the end of adding mapping context, I'm just going to do a get game state, just like that. And I'm going to save it as a variable. So remember, just right click on the turn, promote to variable. I'm going to call it current game state. Going to connect that together. And then so now we just have this reusable variable that we can use. So instead of just running all this just immediately when this is triggered, I'm going to have our game state here. And actually, one thing that I realized, we didn't cast this, so it actually doesn't know that this game state is our game state. So if we say get score, it won't work because it doesn't know what game state this is. So I'm actually going to delete that variable. Before we promote this to a variable, I'm going to cast it. Cast to game state space. So now, if this succeeds, we know that the game state is our game state. And then we can promote it to a variable here at the end, like that. And I'm going to call that current game state. And then now we can drag in current game state down here, and then we can drag off and we can say get is game over. So we're going to get the value of what that Boolean is. And again, we're going to make a branch. So I'll show you a cool trick. If you drag off, don't let go, but just hit B on your keyboard, it will automatically make a branch because they're so commonly used. So trigger is going to run into the branch. And then only if it's true that is game is over, will it reload the level. So just like that. And now we can go back here. So I'll kill a couple enemies. Okay, my score's up to 50. I'll hit enter, and you can see it's not doing anything. I can't reload the game. But if I die and the game's over, I can hit enter and it'll restart the game. Okay, the last thing I want to do before we end this tutorial is I want to fix the enemies not spawning within the camera's range. So I think I know what the issue is, and we'll try it out and see what happens. So let's go back to our player pawn and go to the camera. So one thing is that when you're just playing the game here in the editor and stuff, it's not necessarily the aspect ratio that your finished game is going to have. So sometimes there's a mismatch between what the camera is going to see in your final game and what it sees like here in the editor. So let's go to our camera and our player pawn, and there's a few things I want to change. First is there's this aspect ratio right here. You can see that right now it's 1.77, so whatever. Down here under camera options, there's this checkbox that says constrain aspect ratio. Check that. And then here in the aspect ratio, look, you can set a specific one. So I'm going to do, actually, yeah, let's do 16:9, just standard, whatever, which is what 1.77 was. But the difference is that we did not have constrain aspect ratio. Now, this should fix it. So let's test it. And then I want to do one more thing just to make double sure. So I know one thing this is going to mess up is the player's probably not going to even be on the camera anymore. He's going to be way off the bottom of the screen, and our whole game is going to be zoomed in. So let's see that. Yeah, so the player's way down at the bottom. But as you can see, the enemies are actually spawning off the top of the screen. So what we need to do is we just basically need to come back to our player, and let's just raise our sprite up to, let's try -375. Okay, I like that. A couple things to make note of is, one, the enemies actually aren't spawning off the top of the screen. They're spawning with the center of the enemy actually right, like intersecting with the top of the screen. So I want to add a little bit of an offset to that calculated Z position. And then the other thing is, and we haven't seen it happen here. There we go. So those enemies that spawn left and right, if they spawn as far left or as far right as possible, they're like half on, half off. So I want to make sure that that doesn't happen. So let's go back to the enemy spawner. So the first thing that I was saying that like we don't need to do, but it is safer. So right here, we're getting the ortho width directly from the camera and doing all of our math for the Y and the X directly from that, or sorry, the Y minimum and the Y maximum. However, when we're doing the height, we're using the viewport size, not the camera size. Now, depending on if you have aspect ratios locked, and like I've seen it work this way before, but obviously it wasn't for us. It looks like it's working now, but I just want to be extra sure. So instead, I'm going to drag out from the camera here, and I'm going to do get aspect ratio. We can just get it directly because as you saw down at the bottom here, we were getting the X and Y of the viewport, which isn't necessarily the camera. And then we were using those to calculate the aspect ratio and then using that to calculate the height. So I'm just going to get rid of both of these. And we're going to just grab the aspect ratio of the camera directly. And then by having that, and we, divide the width by the aspect ratio and then multiply by 0.5, this should give us for sure, it's only using camera measurements. And so I'm just going to test that again really quick. Okay. Cool. So now let's just do those safety margins. So you can see the Z spawn, we've got this number for it right here. But the last thing I want to do is before we do that, I actually want to make them spawn, a little bit higher than that. Because right now it's just, the world location plus this exact halfway up. So I'm just going to come off of here and we're going to do an addition node, disconnect that with Alt click. And then I'm just going to add another, 50 to it. And then hook it up. Or let's just do 100 just to be safe. That's probably way too much, but it's going to give the player a little bit of a delay at the beginning before the first enemy actually shows. So let's do that. You might want to mess with that number. If this ends up being way too much, you can change it. I also need to do the same thing for this Y minimum. So instead of just directly connecting that again, in the Y minimum, remember, I want to add to it because I want them to move to the right. So let's add 100 to whatever it is, and that'll move back to the right. This one, I want to subtract the maximum. Since this is now not the whole left side, and we're adding, this is actually going to put it 100 too far to the right. So we need to bring it back by 200. So minus 200. Let's connect that. There we go. So let's give that a try. So now they're definitely spawning off the top of the screen. And I haven't yet seen one be halfway on and halfway off over to the sides. So I think we're fine. And I think that this is going to look good. Obviously, after you follow the tutorial and you make your game, if you notice that they are still spawning with some of them outside, go ahead and, just adjust those numbers. Again, our restart works. So yeah, that's it. That's the whole game. So thank you so much for watching this. I really hope it was useful. Please like and subscribe and turn on notifications. I'm going to be releasing a lot more of these videos in the near future in both Unity and Unreal. And I just want to say one last thing is if you're going to make a 2D game, don't make it in Unreal. That's just my advice. Use Unity if you're going to do something in 2D. But hope you enjoyed it, and I will hopefully have something else up again for everyone soon.